of our scatter, just independent, dependent variable. Like I said, this should be very, very brief. If you're in a stats class, this would be a whole big section. We just have one class to teach it all. All right, classifying relationships. The whole point of using a scatter diagram is real-life data does not follow a perfect line or a perfect arc. It's kind of scattered all over there, and we try to find relationships between those two given variables. So because real data are more likely to be scattered about rather than perfectly lined up, if there is a pattern on the diagram, then there is a relationship between your two variables. We're only worried about 3 different types of relationships in this class today. And that is, there's no relationship. That is that first graph. There is no apparent relationship. They look like they're just completely just shot out of a shotgun, just everywhere. Then we have to ask ourselves, is it possible it's a linear relationship? You know it's linear because if I would draw a line through here, they cluster along that line. And in fact, they look like they're all going up. You can kind of predict where they'd keep going up if they follow that line. The last one we're going to look at is non-linear. This is actually a quadratic, but we don't have to list that. We just have to say it's a non-linear. But we can see it follows this pattern where it goes up, and it kind of comes back down. So if we can draw a line through it, whether it's linear or not, we're going to either say it's linear or it's a non-linear relationship. So 3 things: no apparent relationship, linear, or non-linear. We're going to rapid fire these. Well, we'll go as fast as you guys will allow it because I'm not going to answer these. Raise your hand if you think you know the answer. Top left. What type of relationship is the top left? Yes?
No apparent.
That is no apparent relationship. You should be writing these down. I am not going to because I've already written these down several times. The second one. Raise your hand and tell me what you think that is. Yeah.
Linear.
That is definitely linear. There's a linear relationship. Third one. David?
Non-linear.
That would be non-linear. It's definitely a relationship though, right? Because it does kind of have this arc and comes back down, so that would be a non-linear, but there is a relationship. All right, the bottom left-hand one. Someone new. Okay. It is linear, because we could draw a line that would go straight down. Next one. Linear. Ooh, I drew that diagram on the one. The last one's non-linear. I did draw it on there. I was zoomed in on the wrong one. But the third one is non-linear as well. So the only one that didn't have a relationship was the top left. That's generally what it's going to be. You're going to decide between linear, non-linear, or no apparent. All right, that should be pretty easy. The next part is, and you have 2 of these problems on your homework. I guess I could put this on the test. It's nothing extraordinarily out of the box. It is, the table below shows the year and the number of persons in the labor force in the U.S. So they give us 1960, 1970, 1980, 1990, and 2000. Rather than writing 1990, 1970 all over the place, I just lopped off the 19 and just said we're going to go 50, 60, 70, 80, 90. Well, that means this must be 100 to get me to that 2000. Because this is supposed to be 1900 plus 50, 1900 plus 60, 1900 plus 70, 1900 plus 80, and finally 1900 plus 100, which would give us 2000. And that's what we're going to use in our calculator also. All right, so we are supposed to plot all of these points. So in 1960, our x value is 60, and our y value is 70 for 70 million. Well, that's smack dab in the middle between 60 and 70, so we'll put our point there. For 1970, we're at 82, so when 70 is x, we have to go all the way up to 82. Well, that's going to be slightly above that 80, so maybe about there. In 1980, we're looking at 106, so that might be about here. 1990, we have 125. That might be about here. And in 2000, where our x is 100, we have 141, which is slightly bigger than there. So maybe about there. All right, I did the first thing. A is just make a scatter plot of the data. While I'm looking at that scatter plot, it looks pretty linear to me. It actually looks like almost a straight line. So the next part says draw a line that appears to fit the data. So we're just going to draw a line that hopefully goes through most of these points. depending on how my snap grid is allowing me. Looks like it generally goes through all of them, some higher, some lower. I'm not looking for perfection on these. Yes?
Do we want to bring the line all the way down with the axes?
I would, because I'm going to ask you about 2010, so at least have it all the way up here. All right, the next question is, use your graph to estimate the number of persons in the labor force in 1985. So that means my x equals 85. So I'm going to go ahead and label that. You don't have to label it, but I'm going to. So this is 1985. And to figure out what point that matches up with, you're just going to look straight up and see on that line where it matches. And in fact, I'm going to come across here. And so 85 matches up with, I don't know, that looks like it's more than 110, maybe 112, 113. I'm going to go ahead and pick 112. I think that's what I said at the other class. So I picked 112. And don't forget, it actually is million. I am not looking for hyper perfect exact things where you, I came up with 111, Mr. Pavian, I'm completely wrong. You are not wrong. You're not wrong with 110, 109. I'm looking at where you match stuff up, where it matches up here, bless you. And I'm just making sure you didn't say like 120 or 122 if your graph doesn't show it. Because we're all going to have slightly different lines. So we're all going to have slightly different predictions. So you don't have to come up with exactly 112. Especially in this last one, it says use the graph to predict the number of persons in the labor force in 2010. Well, that's even off our graph. That's 110. Let me go ahead and pick green. So that means we'd have to run all the way up this line. Bless you. Match about there, which is almost right on that line. So I'm just going to say that's 140 plus 20, so that's 160 million. And in fact, in all three of my classes so far, I picked a slightly different value for that. It just all depended on how I drew this line. One class it was slightly lower, one class it was slightly higher. So do the answer that matches your graph, not mine, unless our graphs match perfectly. I'm going to test your brains for a real quick second. Not part of this lesson, but it's part of like stats and stuff you'd work with statistics. Does anyone know what it's called when you're picking a value between our data points? So I have a low data point here and I have a data point here. What's it called if I'm picking something between those 2 points? No, you are. You really are. It's called interpolation. You're interpreting a result within your data. However, you see this green one? It's not within my data set. It is outside my data set. That is called extrapolation. I'm extrapolating, and extrapolating is far less accurate than interpolating because we don't know for a fact. We're zoomed in on this little spot. This line might, as soon as we get to that last data point, we don't know for a fact, it might do this. You know, something could have happened. There could have been a war or something, and it could drop off. All we know is it stays consistent between these, and we're just going off that data to assume it does this and assume it does this. In fact, if I follow this line, we get down to 0 people in the workforce really, really quick when there were probably people working. Yeah, and we'll see what I mean in just a second when we do our first example with our calculator. All right, so that's why extrapolating is less of an exact science than actually interpreting results between our data sets. And that's what I want you to think about when we get to the problem after this one when I ask you about 0 earthquakes. So in math and in stats and in science, we want to know how strong is this relationship. We want to know how strong is this relationship. How close do those points cluster on a line I draw? And what we do is we kind of grade it on a scale between 1 and -1. We call it our correlation coefficient. That tells you how strong that relationship is between those different variables. So we go from 1 all the way to negative 1. The closer you are to 1 or negative 1, the stronger the relationship is between the variables and the straighter the line you can draw, or the more points you'd go through with the line. So we look here on the bottom left. If my correlation is 1, all of my points make a perfectly straight line. Just like at negative 1, we have a perfectly straight line, but it's going down. Now when we start moving closer to 0, we see 0.9. If I drew a line through 0.9, we're going to see that the other points, they kind of vary. They vary away from the line. And the further we get closer to 1 at 0.05, we can see we're getting less and less to the line. And at 0, we have no correlation whatsoever. It's just a scatter of points. The other thing I want to point out here, negative matters. Negative matters, and it tells us what's actually going on. The first thing says correlation is positive when values increase together. So if you have a positive slope on your line, you're going to have a positive R value. If you have a negative slope where your data is going down, like this negative 0.5, negative 0.9, and this negative 1, your slope would be negative as well. So going down gives you a negative correlation. Going up gives you a positive correlation. All right, but I think the meat and potatoes is right here, is using our calculator to come up with these regression lines. So what we're going to do now is, this line we drew here? We're going to ask our calculator to draw a better line, one that's as close to matching our data as possible. So we are going to use our calculator. And before we even use our calculator, I want to point out this top right section here. You do not need to do this every time. You just have to do it once. And as long as you don't reset or do something crazy to your calculator, it will stay in the proper mode. And this is just going to allow us to come up with a regression line. All right, so you don't need to do this every single time. It's just to make sure your calculator's in the right space to do it. It's kind of like checking your mode before you graph something. We're just going to make sure our diagnostic is on. So that's the very first thing I'm going to do. I'm going to go ahead and open my calculator. I'm going to turn it on, hopefully, if it lets me. There we go. And what we're going to do is we're going to go to our catalog. Notice our catalog button is right down here at the 0. We're going to hit second catalog, so that's second 0. Now we could scroll all the way down till we get to diagnostic on, but it's a waste of time. There's a whole bunch of letters. So if we see all these green letters here, we can skip to, let's say I want to pick L's, I would just pick an L. Well, we want to get down to D. Well, D is that X to the negative 1 button. You do not need to hit alpha. It's already in alpha mode. That's what that top right means in your screen. It should have a little alpha button. All you have to do is hit X to the negative 1 or X inverse, and you're going to get to your D section, and you are going to scroll down until you get to your diagnostic on. So I'm going to go ahead and hit enter. And now I'm going to hit enter one more, and then it'll say it's done. You got it. We are good. Can we view my keystrokes, key history?
Enable skin. Enable skin.
Let's clear these. Okay. So I am now diagnostic mode on. Now we're ready to do what we're going to do. Now let's go back here. These are the directions of what we're doing. I'm going to go through it with you. We're going to go through this example together, how to solve it. So we have a table showing the number of earthquakes worldwide with a magnitude between 5 and 9. So what I'm going to quickly do is, we have years. That must be my independent variable, so that's going to be my X. And depending on the year is the number of earthquakes, so this must be my Y. X-axis, Y-axis, we got that taken care of. It says use a linear regression on your calculator to find the regression. It also says let X equals 0 correspond to 2000. So I'm not going to type in 2000, 2001. I'm just going to type in 0, 1, 2, 3, 4, 5, and 6 for those. Let's go back to our calculator to plug those in. Today, your big button is going to be this stat button right here. So it's your stat button almost next to your arrow key. So I'm going to go ahead and hit my stat button. And then I'm going to go ahead and hit enter to edit my rows. Well, mine are all good because mine are from the other class. But what I want you to do is we're going to match this table up with the table that we see right here. So I'm going to, in my top left, I'm just going to hit 0. And then I'm going to hit enter. And that will put a 0 in there. Then I'll hit 1, enter. If I have any values in here that I don't want, you can also hit delete. So let's say I'm scrolling down, and I happen to have, scroll down too far. Let's say I had an 8 down here. That's too far, so I would just go up there and I would hit the delete button, and that eliminates something. Your delete key is going to be the key that deletes information. All right, so what I want you to do right now is type in all that information into your stats. Oops, you just moved it. And I'll give you a second to do that. Yeah.
Wait, what?
So now, resuming, we are going to hit second, quit, to go back to this screen. Then what we're going to do is we're going to go to our y equals, and we're going to clear anything out of our y equals, because I don't want to have anything else on here. And then what we're going to do is we're going to hit second y equals again, which says stat plot. We are going to plot those points we just inserted into our calculator. And you're going to make sure all of yours are off except for the first one. We're going to turn that one on. All of them should probably be off on yours already.
Yes, sir.
And my advice is, as soon as you're done with this homework, turn all of them off again so you don't mess stuff up later on. So I'm going to turn this plot. Let's pretend that plot 1 isn't on. I'm going to go ahead and hit enter. And right now your plot will be off, and this will be flashing. Just go ahead and hit enter. So let's match what yours might look like. Yours probably looks like that. And we're going to hit enter on. Now your stat plot is on. Now we're going to go ahead and graph it. So we're going to go to that graph button. Did anyone else say that? Oh, yours is fine. I want to show you something. If you ever see this dimension mismatch, what that means is, I'm going to go back to my stats. You don't have to because yours should be fine. Edit. What you're going to do is you're going to scroll down. Do you see that 6?
Oh, sneaky 6.
That sneaky 6? I don't have any information there, so that's what that dimensional mismatch would mean. So that, you'd go back here and say, well, that one should have been, what, 2190? No, wait a minute. Oh, I know what I did. I didn't delete it. I actually inserted a row. So I just got to fix this real quick. 1. It doesn't look like mine yet.
Mine looks like a
That's because your calculator zoomed in where the last place you zoomed in was. Normally it's standard. So what you're going to do is you're going to hit your zoom button. You're going to say, I want to find my data, Mr. Calculator. And he will be able to do that because you're going to go down all the way to number 9, which is zoom stat. That will zoom in on just your statistics that you plugged in. And as soon as we hit enter, you're going to have a graph that looks a lot like mine. Plot, yeah.
It's so pretty.
Whoa. How'd you do that, Nick?
I don't know if I just trying to look. It looks like a sausage. Or a chicken rash.
Yeah, I'm not sure what that is. I'll have to look at it in a bit. I'm not sure what's... So you have the wrong graph on. So we'll go to our stat plot.
I need to go to that and then click on that one.
Yep. Yep.
Okay.
There you go. All right, does everyone have a graph that looks like mine so far?
Yes. Yes.
All right, now I want to find that line of best fit. In fact, this is the most important part. So David, yours isn't graphing right now, but this is the most important part of this lesson, is coming up with that linear equation that's going to go through all of these points. And in order to do that, we're going to hit second quit. All the graphing stuff is kind of extra. This is what I think is the most important part of this. And that is, we are going to go back to our stat button. And we're going to tell it that I want to calculate that linear regression, that line that goes through all of our data. So we're going to go to calculate because that's what we want to do. We want to calculate something. And you are going to scroll down until you get to this linear regression AX plus B. Some of yours have other ones. There's more buried up. But this is the one you want, AX plus B. I'm going to go ahead and hit enter. It should bring you back to the home screen. You're going to hit enter again, and it's going to give you your A value is 117.4, because I'm going to round. That goes in for that A. And our B value is 1,269.1. I'm going to plug that in for my B. Yes?
Well, I hit enter, it brought me to an X list.
Yeah.
And then Y list.
Oh, you can just go down to calculate and then put enter.
Yeah, some of those are calculate.
So hit enter and go with this. Yes.
Calculate.
Okay.
Yep, some of yours have calculate. Mine doesn't. Mine does not have calculate. Mine goes, I have an older one on here.
Oh, mine's on that.
All right, but you should, did we all come up with these values?
Oh, yeah.
Yep.
Did we all come up with these values? Okay, then I'm going to move on. All right, so all you're going to do is you're going to take those values and you're going to round them to the tenths place. And we're going to write that equation. We're going to write this as y equals 117.4x plus 1269.1.
I got like your A value I got for B and then your B value today.
You must have stuff flipped. I'll have to look at that in a second. Do you have your L1? Do you have your columns that look just like mine? Did you put your X value in your L1 and your Y? To predict the number of earthquakes in 2015. So 2015 equal 15. This is asking when is X equal to 15, because 15 stands in the place of 2015. So we just need to put 15 in for our X value. So we have Y equals 117.4 times 15 plus 1269.1. Which when I plug this in, you come up with 3030.1. All right, we're going to run a bit long because of the calculators. I also have to show you how you do that on your calculator. Actually, let's just skip. No, let's do it. I just don't want to run our whole class because that's what we're going to do. We're going to learn how to plug this in our calculator, that specific line. And how to do that, what we're going to do is we're going to go to our y equals screen. We're going to go to our y equals screen. This is how we're going to let our calculator find that x value for us. We go to that y equals screen, and all these directions are right above, so I'm going to kind of rush through it. You're going to hit the vars button once you're at the y equals. We're going to hit our vars button. And what you're going to do is you're going to scroll down to statistics, because that's what we're dealing with. We're dealing with statistics.
Where's that button, the bars?
Right here. And then we're going to go ahead and hit enter on statistics. We're going to slide over 2 to get to our equation. And right now it's telling you, it's putting the equation that we just did. This is our regression equation. And we're going to hit enter on regression equation. And you're going to see your regression equation is plugged into y equals. Not rounded or anything. You could also type in the rounded one as well.
The whole thing.
Yeah. Or rounded. All right, then if you hit graph, you're going to see the line go straight through. So that's how you're going to let your calculator graph it for you. And now what you could do, which we practiced before, is hit second table. And you could scroll down to 15 and see the actual answer was 30, 30, not 30, 30.1. That is the exact answer, would be 30, 30.
Is table the same thing as table set?
No. Table set would tell you where to start at. Table is right by graph. You have a graph and a table.
Oh.
Because your table is plotting all those points. These are all the points that were plotted. All right, questions on that? Because I'm sure people's calculators aren't working in this class for some reason.
How far?
Yeah.
How long does it
Wait, how'd you get it to show 30, 30?
I just scrolled down the x values. So I went second table. And I scrolled down until I got to when x equals 15. And I got 30, 30. Does your table not work?
Yeah, it graphed the line.
Okay, then hit second table.
Oh, Oh, from the graph.
It doesn't matter where you are. The table's right here.
Oh.
There you go.
In 30 times, there will be 14,182.
And that's the super useful part about plugging your calculator, because if I asked a whole bunch of questions, like if I said in 2050, how many people are there? In 2060, you can rapidly do that versus someone that has to plug it in every single time. So that's how you could solve that same thing by using your calculator. All right, let's get to the last one. The last one says, according to the equation, in what year were there no earthquakes? So remember, number of earthquakes is our y value. So we're looking for when y equals 0.
We just solve them.
Yeah, this is when there's no earthquakes. So if I put y equals 0 in, we'll have 0 equals 117.4 times x plus 1269.1. Well, let's just rapidly solve for this. Well, I'd subtract 1,269.1 from both sides, and then I would divide by 117.4, which will give me x equals a negative 1269.1 divided by that 117.4, which you should come up with about negative 11. But negative 11 is not your answer, and I will not give you all the points for negative 11. Because if I said, what year were there no earthquakes, and you told me negative 11, that didn't give me, how do I get my actual year? Yeah.
You subtract, or you added rather, to 2,000.
Yep, so we'll have 2,000 plus negative 11. In other words, subtracting 11 would equal 1989. Does that, if you go back to 1989, were there no earthquakes there?
No.
There was definitely earthquakes. That's the problem with extrapolating information, because that's a big error in this. We only know that this matches this data between. Anything outside of it, we're not sure it's going to work. All right, the rest of the time will be yours. I have to hand out tests, and then possibly I'll get around